Hello, everyone. My name is Nia, and welcome to today's webinar. We'd like to give everyone a minute to join and settle in. So please use the chat to let us know where you're tuning in from. I myself am tuning in from New York City. Make sure when you're putting in the chat the location that you're tuning in from, you put to everyone so that there may be someone that's attending this webinar in the same location as you. Thank you for dropping your locations in the chat as we settle in. See some people from New York, Chicago, Indiana, Texas, Nigeria, Ethiopia. Welcome. And make sure you're putting to everyone so there may be someone in the same location as you. New York City. I am located in New York City myself. Egypt, Argentina, Mexico, Houston. Right, looks like we have a good amount of people. I'm loving this. That means we're going to have an interactive session. So make sure you do have some questions for our Associate Solutions Architect on the call, Irvin, who will be answering your questions in the Q&A section. But I'll go into that in a second. So since we do have a good amount of people, I'm going to go ahead and get started. I'm happy to welcome you all to today's webinar, Intro to Data Modeling. We have Michael Lin in today's presentation, and we have Irvin, our Associate Solutions Architect, answering your questions in the Q&A panel, and we'll also do a live Q&A at the end. But before we hop into today's presentation, we're going to go over a couple of quick housekeeping notes. This webinar recording will be shared later this week via email. All participants will be muted. So if you do have a question, make sure you're dropping it in our Q&A box, which is located on your Zoom panel. The chat is for live comments, general discussion only. So if you do have any questions, like I said, that you do want to ask, please drop that in the Q&A so we can properly keep track of them. There will also be a short poll that is launched at the end of the presentation before we hop into the Q&A. So please take a moment to fill that out. We'd greatly appreciate your feedback. Now on to today's presentation.
What is data modeling? I know you're all joining with that question in mind, and I'm going to answer it today. We're going to take a look at the difference between RDBMS and MongoDB. We're going to look at relationships in data and how we represent those relationships through the process of linking data elements versus embedding them. And then we're going to take a look at some design patterns for commonly expressed relationships between data elements, whether it be one-to-one, one-to-many, or many-to-many. If you come away from this webinar today with one thing, I'm hearing some feedback. Diego, yeah, there you go. If you come away from this webinar with one thing in mind, I want you to remember this mantra. This is a mantra that I use whenever I start a data modeling project with MongoDB. Data that is accessed together should definitely be stored together. Okay, I'm going to explain a little bit more about this as we go forward, but I'll be referencing this slide and our mantra throughout the webinar today. So let's talk about what data modeling is. What is data modeling? Well, it's simply put, the process of figuring out how to represent and store data in your database. Okay, why is data modeling so important? There are several benefits. The first of which is better performance. When you model your data effectively, efficiently, your applications will perform better and your users are going to be more happy. The implementation of your application will be simpler. You'll lower costs associated with storing your data and managing it, and your application will have better adaptability going forward. Why then is data modeling so often overlooked when it comes to MongoDB? Well, there are several reasons, but the first is that people have this concept of no SQL, not only SQL, and they feel like they don't have to do that data modeling exercise with a NoSQL database. Well, let's strike that term from our vernacular.
Excuse the Wi-Fi as it is loading. It is currently loading, so there is still audio, but the video is buffering as it has paused. But please give us a moment. Thank you for your patience.
Do that data modeling exercise with a NoSQL database. Well, let's strike that term from our vernacular.
There currently isn't any sound due to the video currently buffering, so please give us a second to fix this on the back end. Thank you.
What is data modeling vernacular today? You may also have heard the term non-relational. We're going to strike that term too. We're going to start using the term non-tabular. Okay, when we talk about MongoDB being a document-based database, we're going to call it non-tabular because there are no tables. And speaking of vernacular and vocabulary, here are some common phrases that I'm going to be using today. in our journey to understand data modeling in MongoDB. First of which is database. It's the same in MongoDB between non-tabular, relational, and MongoDB. The second is collection. It's more common in the tabular space to call data entities stored in a table. We're going to refer to those as being stored documents in a collection. Parent-child tables in RDBMS, they become nested subdocuments or arrays. Indexes are common between RDBMS and MongoDB. And where you see a row in a table in RDBMS, we're going to refer to that as a document of fields. And then a column becomes a field, and a join in RDBMS, if you're coming to us from SQL, MySQL, one of those tabular databases, you are probably familiar with the concept of joining data because you have to be in a normalized world. We're going to refer to that as embedding or linking, and we use the term $lookup to refer to an operator that enables us to join data between data in multiple collections in MongoDB. So I hope you'll come back to this in the future when you are curious about some of the vocabulary that we're referencing today. There are other non-tabular databases. We're going to focus today on document databases because MongoDB is firmly in the world of document databases, although we do support additional types of indexes, but we're going to restrict our information today to document databases. So then what is a document? This is a document, and many of the programmers among you, developers, will say, I recognize that, it looks like JSON. It sure does. It's because it is. When we refer to the data that's stored in MongoDB, it looks like JSON, tastes like JSON, smells like JSON. JavaScript object notation. It begins with a curly brace, and it ends with a curly brace. And in between, where the fun happens, these are key value pairs. These are fields. Okay, so keys are always going to be string. Title, for example, is a string. The value can be a string, it can be a number, it can be an array, it can even be another document. In the case of reviews, we have an array of additional documents. So if you're brand new to document databases, this might look a little strange, but don't worry, we're going to explain it. These book documents go into a collection of documents. So we have many of these book documents in our collection, and we're going to reference exactly how we lay this out. Another reason that people think they can overlook data modeling in MongoDB is that there's this concept of schema-lessness in MongoDB. There's no schema, right? Well, no, it's not actually a schemaless database. And it is not equivalent to a JSON data store because we store this data on disk using something called BSON, a BSON representation of the JSON data. That enables us to be very rich in the types of data that we store. We store more types of data than JSON supports. Date types, for example. In JSON, they're stored as strings. In BSON, they're stored as fully supported date objects. This helps us when we develop code. With RDBMS, every database has an explicit schema, and that lives outside, separate from the data. The schema in RDBMS lives separately from the data. Whereas with MongoDB, it lives in the data. With MongoDB, we say that every document has an implicit schema, and from document to document in a single collection, we can have different schemas. This is called polymorphism. Poly meaning many, morphism meaning shapes, many shapes. We also refer to this as schema on read. The schema exists when you read the data and look at it. Okay, so this also supports a greater level of flexibility. When I want to, let's say, add a field to my data, looking at our book document here, I want to add, let's say, publisher and a schema version. I can simply add those fields to my data, changing the schema in this particular document. This supports greater developer velocity. We can just simply modify our code to increase the fields that we're supporting in our application. And if you wanted to look at maybe a snippet of JavaScript, this is what that might look like. This is using the Mongoose library It's referred to as an ODM or an ORM. And we're adding publisher and schema version. Now, you don't have to use Mongoose. You can simply write native JavaScript code. But that is an example for you. So one last reason why data modeling is often overlooked with MongoDB is that folks have this idea that they can come to MongoDB and simply leverage the same design patterns that they used in the RDBMS or tabular world. This is going to lead to poor performance in almost every case. This is why you need to pay attention to webinars like this, data modeling for MongoDB specifically. We're going to help you build a data model for your application so that you'll have fast, efficient access to your data. So then, what does data modeling look like for a document database? Let's take a look. This is one of the most important slides. I want you all to stop what you're doing, stop checking email, look at the screen, screenshot it. This is the secret sauce. This is the recipe that is going to enable you to build an effective data model for any application you're writing. This is a generally applicable set of 5 rules. The first, screenshot. Yes, definitely. Stop breathing. No, don't stop breathing, Claudio. Okay, so the first is you want to always begin the process of data modeling with MongoDB by collecting your system and application requirements. What requirements of the application are there? We're going to get into that. 2, identify the database entities and their properties. Now, this is a tricky task, but I'm going to help you understand exactly how to do this. And I'm going to even give you a little template that'll help you get started there. 3, determine the database workloads. This is the access patterns of your application. You need to understand these before you begin to nail down your data model for MongoDB. You want to write these down, write down the common operations and the frequency, and take a guess at the criticality of each of those workloads. 4, you want to identify the relationship between the entities in the application, choosing between an embedding model and a referencing model. Now, I haven't explained what embedding or referencing is yet, so hold on to that concept. You can just kind of put that in cache. 5, apply appropriate design patterns if and when necessary. We're going to give you some of those design patterns. That was one of those links from the beginning. When we talk about collecting system and application requirements, there's a couple of categories of requirements that we're going to have with every application. The first is your functional requirements. How does the application need to function? And you can look at this through the lens of the types of users that you have. Typically, we have at least 2 classes of users for every application. There's going to be regular users, and there's going to be administrators. And in today's case, we're going to call those administrative users librarians because we're going to work on a library application. That's the lens that we're going to view data modeling through today. I can't really understand exactly what you're building today, but I'm going to use a fairly generally applicable application for a library because we've all read books, right? And the last category of requirements is going to be performance requirements. How much data and what are the expectations around the volumes of data and the speed? Okay. So I explained this already. We're going to be working on a library management system. We've all been to a library, or at least understand the concept of a library. Let's look at our functional requirements. Now, this is a really dense slide. I don't want you to sit here and read all of these things, but we do need to take time to examine our requirements. And as I mentioned, we have 2 classes of users in our fictional application, readers and administrators or librarians. Let's look at our reader requirements first. A reader in a library is going to want to always browse a catalog of available books. That's a fairly straightforward functional requirement. Second, view the extended details of a book, right? So if you click on a book, you want to see more details. You want to be able to reserve a book and check it out. You want to be able to see a list of all the reservations, the book loans that you've had. You want to be able to see all the books that you borrowed, and then view the details of an author. Let's look at other books that this author may have published. From a librarian's perspective, they're going to want to see a list of all reservations that have taken place and their expiration time, a list of all borrowed books, including the due date. They're going to want to filter reservations by borrowed books by user, and then they're going to want to actually execute the process of lending a book to a reader. and mark that book as returned when they bring it back. So the second category, as I mentioned, is performance requirements. Let's look at our data. Now, some of this you may have, and some of this you may have to guess at, and it's okay to guess, but you do need to do some of this work before you begin your data modeling process. In our library, we have about 10,000 active readers. We have 250,000 books. Readers are going to consult the library website on a weekly basis, typically, and borrow books every month. Most readers are going to reserve and borrow about 3 books a month. These are guesses and they're estimates. Reservations can be made online through the application, but books can only be borrowed on site. And our readers rarely read more than 3 book reviews. The system we're writing is going to support reviews. Okay, I love that. We're getting some great questions in the Q&A box. Keep those coming. We're going to end in approximately 30 minutes, and we're going to answer some of these questions live. So keep those coming. In terms of our expectations, the book details page is going to show book availability, and it should refresh. It should show the details in less than 300 milliseconds. That's a typical response time for any application. 300 to 500 milliseconds is generally acceptable. Readers should be able to reserve a book in less than 3 seconds. It's got to be snappy. We want really good response time. Librarians should be able to lend a book or mark a book as returned in less than 3 seconds. And readers should be able to see the list with all of their reservations and borrowed book in less than 500 milliseconds. So this is a pretty good, well-defined set of performance requirements. And you may have some of these details and you may not. It's okay to make estimates. My mouse kind of went nuts there. So if we were to look at what this application might look like, here is the opening screen for our application. Here you can see a nice banner. That link is actually functional. It's going to take you to this example application. I won't be able to answer questions about details about this application if you do go to that link, but I'll do my best. And then, so what you see here is a tiled list of all the books that are available, and we're going to go a little bit deeper into that application shortly. So let's talk about a methodology for understanding how we can begin to model data for our application. This is a really great kind of waterfall flow of activities that you're going to undertake when you start to model your data. We start with entities, okay? Start with understanding what the elements in the data, understand their sizes, and let's dive into that. What are the main entities that are used in our system and that we're going to be storing in our database? And what are the properties of these entities? So for example, every reservation has a due date, every review has a score, every book has a title. This is going to be the process of looking at what our application is going to manage in terms of data. That's going to help us before we start talking about the relationships and how to lay it out on disk. I've done the process here for you for this fictitious library application, but you're going to want to go through in detail and answer all of these questions specifically. Let's take a look at one of the entities in our application. Authors represent something unique because there is a relationship between books and authors. And this relationship could be represented in one of several ways. It is a book property, but is it a separate entity? In the relational world, you would almost always create a separate table for your authors. In the non-tabular world, you do not have to do that. And I'm going to show you how to determine whether you would reference or embed. Let's take a look at that. So our properties for authors, they have names, they have aliases, and their names are not unique, okay? So let's go back to our functional requirements to shed some light on whether or not this should be a separate entity or a separate collection. And the final set of functional requirements is going to give us a clue. We have to be able to support the workload where a user can view the details for an author, including all of the books that they have published. Okay, this is a clue. View the details for a specific author, including all their books. This is an access pattern that I'm going to show you. This is a GIF that, okay, so I'm looking at the main screen here and I'm going to click on an author. Let's go to F. Scott Fitzgerald. And here I show all the details for that author as well as the additional books that they published. This workload, this use case, this access pattern is a clue that we may need to treat authors as a separate entity. The query is going to be separate from books. Okay. So in this case, I may choose to store authors as a separate entity. Back to our mantra, data that is accessed together should be stored together, but on the flip side, data that is accessed separately should be stored separately. If I were looking at this from the perspective of an entity relationship diagram, and imagine that that little thin line between in the center is separating the world of relational database management systems on the left from the world of document databases on the right. If I were to store authors as a separate entity, this is what my entity relationship diagram for MongoDB would look like on the right. Okay, on the left, I'm normalizing the data and separating it always. There's a separate table for authors always. But on the right, I have a choice. I have embedded some of the data for books, and I've separated into a separate collection authors. If I were to reference this in code, JavaScript specifically, this is what a find one might look like. Database.collection, authors, and I may find one based on a filter. Okay. Now, conversely, if I wanted to treat authors as an embedded element in my books collection, this is what that data model would look like. Again, on the left, we have our relational model where we've normalized our data into separate tables. But on the right, I'm representing the MongoDB data model where I've embedded author, name, and biography right in the same document in the books collection. Okay, so this is a comparison and contrasting and referencing model versus an embedding model. I hope this is beginning to make sense for you. If not, please feel free to use the Q&A box to ask questions. Data that is accessed together should be stored together. I hope this is getting drilled into your head. I hope this becomes your mantra when you begin to do data modeling with MongoDB. And the converse side of that, the flip side, is data that is accessed separately should be stored separately. So in this case, authors are going to be stored separately. So we'll need to join that data. Let's take a look at workloads. In our waterfall, we've gone from defining our entities to now discovering and documenting our workloads. We're going to quantify the operations and qualify those operations. So don't skip this step. Please understand your workloads. In the relational world, you can just begin to normalize your data before you really truly understand what the workloads look like. In MongoDB, the importance of this step is paramount. How many requests are you going to expect? How critical are these operations? And what type of latency is reasonable? These are questions you're going to want to ask yourself in every case. Here's your template for your workloads. I want you to define the type, the operation first, the information required, the frequency of the operation, and its criticality. So the first workload that we're going to look at is showing book details. Okay, what type of operation is that? Is it a read or a write operation? Well, show book details, I mean, it almost answers itself. It's a read operation, but what types of information are we going to, good answer. It is read. So what information are we going to show? We looked at our application and it looked pretty clear. There's title, but some other information. Let's go back to our functional requirements and answer this question. Our second requirement was that we be able to view the extended details of a book, including author, synopsis, title, physical copies, reviews, and other readers. Okay, so I'm so glad that we took the time to document our functional requirements, because now we can go back and look at what that might look like in our application and then document it in our table. We're going to require book title, cover, author, reviews, and availability. Let's go back to our requirements and look at our performance requirements so we can further answer this workload question. Readers rarely read more than 5 book reviews. So that tells us that for this specific exercise, we only need to support 5 book reviews. Okay, so the operation is gonna reference at least 5 reviews, or the last 5 reviews, sorry. And what is the frequency? Okay, back to our requirements. The library has 10,000 active readers. Well, As much as I hate to do it, math enters our life in so many different ways. We need to do the math to understand what the requirements for application is going to be. The library has 10,000 readers. Okay, well, that's divided by 7 days. So if we want to get to a daily figure about the number of users, active users per day, so 1,400 users per day. But what does that mean? It doesn't mean anything unless we start to look at the volumes of data. Well, okay, so we said they're going to read on average 3 books every month. So that means 4,200 rented books. Our application is doing pretty good, and we might be able to go public soon. How many books do readers browse before reserving? We're going to have to take a guess at that. Let's assume 25. So if we do the math, we extend the math, we have 4,200 rented books times 25, which is our estimate. That's about 105,000 book views. And if we assume that each book document, based on the entity data that we provided, is going to be less than 1,000 kilobytes, then we can do the math. 1,000 kilobytes times, the slide is incorrect, but we'll fix that. 105,000 views, that's about 1.2 megabytes of data. So fairly low volumes of data. We're not going to have to shard this for sure. So we'll document that. We have 100,000 K per day, which is equivalent to about a megabyte per day. This gives us a criticality of a medium. And we can do this exercise for literally every one of our operations. We don't have time today to go through each one of these, but I want you to understand the methodology that we follow. This is the data modeling methodology that we follow for literally every data modeling exercise. And I want to give a shout out to the folks. There's a portion of the developer advocacy team at MongoDB that do these exercises with customers. So if you're a customer of MongoDB and you're interested in having someone go through a design review, there's a specific team. So reach out to your enterprise account executive and ask them about the design review team. And we'll go through this process with you. Let's move on from workloads to further defining the relationships. Okay, now that we understand the basic entities, we understand how those entities are used in our workloads. Now we want to understand the relationships between the data, and we can begin to bake our data model. Remember our mantra. This is so important. I'm not even going to say it. I want you guys to say it. Data that is accessed together. Good. Okay, I can almost hear you saying it. Data that is accessed together should be stored together. All right, so let's look at some relationships. There are several common patterns, and this is regardless of the type of database that you're using. There are relationships. Yes, I love it. Together, yes. Nice work. So there are several types of common relationships between data elements, and these exist across any type of database that you're using. There's going to always be this one-to-one relationship. So for example, we have one title for every book. Books don't commonly have more than one title. And if they do, we're probably going to store it in a separate book document anyway. So it's still going to be a one-to-one relationship. This is what that would look like if that were the only data element. We would have a book document with a title. Okay, so for one book, we have one title. That's a one-to-one relationship. There is another type, which is one-to-n or one-to-many. And a good example of that is book genres. One book, Brave New World, can exist in many different genres. It can be science fiction, it can be dystopian, it can be a novel. Okay, that's a one-to-many relationship. And there are also, there's also a trickier, this is a more difficult pattern of relationship to understand, but it's many to many. So a good example of this is authors to books. One book may have many authors, and one author may have many books. That's a many to many relationship. Now we can even further refine this, but we'll put that on the shelf for a moment. We're going to talk a little bit more about embedding versus referencing. I showed you an example of this earlier. We're going to go a little bit deeper into this. Now, we showed you the document that represents the book. We're storing our book details in a document in MongoDB, and this is what that looks like. Take a look at the reviews field. So our review field is embedding an array. That square bracket is indication that there's an array of data underneath this field. Okay. And this can be n elements in an array, and each element is another document. So each review has a user field and a text field. And I would imagine it would have a rating as well. This is kind of an abbreviated example. So here's our embedded field, reviews. So when we look at the one-to-many relationships, when we embed, there are several ways to represent that. We can embed on the one side or on the many side. If we embed the data on the many side, then we are going to create a separate entity for reviews. We would flip the book data model and store on the many side. And what you're seeing there is a collection of review documents which back reference the book. And I might actually include an ID in the book field. There's our embedded book reference. Now, this does lead to duplication of data, which is a giant no-no in the tabular world. To normalize data is to reduce duplication, but we don't care about that in MongoDB unless it impacts our performance requirements. You can also reference on the one side, and this is what I was talking about earlier, where the book document would contain a reference to the reviews collection. So here on the one side, we have the book, which has a many side, which is a review. So the left side is going to be a collection of books, and there's going to be a unique identifier of an array of reviews in the book document, which reference elements in the review collection. So here's our embedding, our embedded reference of IDs to each of the reviews in our reviews collection. So this is a one-to-many example where we're embedding and referencing on the one side. Okay, and here's an example of referencing on the many side. Again, we flip that around where we have an ID, a book ID, and reviews contain a back reference to our book. So there's many ways to reference this. And again, the answer is, it depends. How do I know whether to reference on the one or the many side? It depends on the access pattern of your application and the performance requirements that you documented earlier. So you're always going to go back to that process of documenting your entities, your workloads, and the use case that you want to support. Now, there are some things to remember about these two ways of representing relationships, whether you choose to embed or you choose to reference. First, embedding is going to lead to a single query to retrieve all of your data. The more you embed, the less you have to read. A single operation is going to be required to update or delete data in an embedded model. This does lead to data duplication. And it also can lead to large documents. Does anybody know, I'm going to ask a little trivia question. Does anybody know the maximum document size supported by MongoDB? Yeah, right. Yes, it's 16 megabyte. Several people got it. 16 megabytes is the maximum size you can store a document. That's a pretty big document, by the way. There are ways you can use GridFS, by the way, if you want to store a set of documents larger than 16 megabytes. On the referencing side, well, there is no duplication. Okay, so you're gonna break things down. You're not going to duplicate data. This leads to larger numbers of documents. But now you have to figure out how to join that data the same way that you do in the relational world. And again, I gave you a clue earlier. The operator that you're going to want to reference is $lookup. There are several others, but $lookup is the main one. So this comes down to a choice. Is it the red pill for embedding or the blue pill for referencing? Who gets that reference? So cardinality is something that you need to consider when you make this choice. Yes, it is. It's a BSON imposed limit. Yep. So cardinality, as it relates to expressing these relationships, in a one-to-few, you're going to access them together. They're going to belong to one entity. And an example of one-to-few is books to genres. It's probably not going to be a zillion genres. It's going to be a relatively smaller number. And users to addresses. How many addresses can a single, or does typically a user have? Not many. It's going to be few. So an example of this, embedding on the one side for a one to few relationship would look like this, where we're embedding addresses for a user in an array. One of the anti-patterns that we reference in when we data model for MongoDB, an anti-pattern is storing large numbers of elements in an array. It's not going to be a good idea because if you have to traverse that array, it's going to cost you in terms of performance. Okay, so take a look at cardinality. So when you have a one to few, like users to addresses, leverage embedding on the one side. Let's take a look at the other opposite end of the scale, one to zillions. So an example of this would be like an article page to views or visits. You could have zillions of views on a particular article, right? Or process log messages. There's going to be zillions of those depending on the frequency of your application. So in this case, there's really no risk of exceeding the document size limit when you reference on the many side, okay? Because the document's going to be very small, but there's going to be very many of them. But you should be extra careful when querying the zillions collection because it's going to be very costly. And you're going to want to take a look at indexing to support a very performant workload. This is an example of one to zillions, and we talked about articles and page views. And the last one that I want to show is one to many. So you need to ask yourself, are you going to access both elements separately very often? If you are, then you want to reference usually on the many side of the equation. If not, then embed on the more often queried side. And if you're not sure, reference unless you're looking for simplicity and you're not afraid to migrate later. So some good advice there. Here's another template for you. It'll help you answer the questions around relationships between entities, and it will help you quantify them in terms of the common relationship patterns that we talked about: one to one, one to few, one to many, and many to many. Okay, so you're going to answer the question embedding or referencing, and we always want to go back to our functional requirements. The last one gives us a clue. View the details for an author, including all the books they have published. This is going to be queried separately. Okay, so this always goes back to our functional requirements. And in this case, I'm going to most likely choose storing authors separately. Okay, so this is what that would look like. Author is a separate collection of documents. And then I'm going to store authors in an array because it's not always going to be a single element. There might be multiple authors for a single book. Okay, so we'll answer that question and we'll document it. By the way, can't stress this enough. You really should have good documentation about the choices you made for designing your data model. It's going to help you when you're working with other developers. Here are some guidelines that you can use to determine whether or not you should be embedding or referencing. We have some simple guidelines. Okay, so simplicity's sake tells you, would you be keeping the pieces of information together to keep your data model simple? Then just embed. I love this because it leans toward our mantra: data that is accessed together should be stored together. We like to keep it simple. I'm not going to go through each one of these for the sake of time, but these are our guidelines. Maybe put a little bookmark in the time. We're at 40 minutes in. You can come back to this and read all of those. We're going to further define the relationships between our data elements, and we're going to document those. In our library application, we've got a book-author relationship, we've got a user-borrowed book relationship, we've got a user reservation, and a book reservation, and a book review. And here we're making, in almost every case, we're making the choice to reference rather than embed. That's not always the case, but for our specific application, that makes sense based on our functional requirements and our performance requirements. Lastly, I want to talk a little bit about the patterns, some design patterns, and then we're going to wrap and take some questions. So, common design schema design patterns. There's a computation design pattern where you can pre-compute data and store that in your data model, in your schema. There's a grouping where you can group common data elements or calculated data elements in your data model. There's a lifecycle pattern where you're going to, ahead of time, think about the archival lifecycle for each document. This is going to give you the ability to automatically archive data. And you can use things like a time to live index where your documents are moved out of the collection over time. There's the polymorphic design pattern where each document in your collection can have a unique design. It can have a different shape. And what that supports is a single collection. And lastly, there's the relationship design pattern guideline. And I want to point out that these design patterns are documented fully in a blog article that's on the MongoDB blog. It's under data modeling design patterns.
Thank you so much, everyone, for joining today's webinar. We just launched the poll, so please take a moment to fill that out. But before we hop into Q&A today, we're going to go over our new learning path. The new free online MongoDB data modeling path will show you a step-by-step method for creating effective data models. You'll learn how to identify entities and workloads, map relationships, and when to embed our reference them. In addition, you'll learn different schema design patterns, how to recognize and address MongoDB anti-patterns, and the basics of schema lifecycle management. Upon completing the learning path, not only will you feel prepared to take the certification exam, but you'll also automatically unlock a 50% discount on the exam. You will receive an email with code that you can use at checkout when you schedule your exam. I'll drop some links in the chat so you guys can access the data modeling learning path. And the poll was dropped, so please take a moment to fill that out. I'm going to hand it over to our Associate Solutions Architect, Irvin, to answer the questions that are in the Q&A. Again, thank you everyone for joining. So if you do have any questions, please drop them in the Q&A. We only have about like 5 minutes until this webinar wraps. So please take a moment to do that while you are on with us. I'm going to hand this over to Irvin. Thanks again, everyone.
Hey everyone, my name is Irvin. I'm an Associate Solutions Architect here with MongoDB. If you have any questions, feel free to ask in the Q&A box that you can select at the bottom of your screen, and I will be more than happy to answer any of your questions regarding data modeling.
Also, if you joined late, no worries. The webinar recording will be shared later this week on Friday, so please keep a lookout for that. The slides will not be shared, but you'll be able to pause, stop, and watch the webinar as many times over as you'd like. And also we do have additional resources as well that will be shared too, that were shared within the presentation and also in the chat today. But please make sure you drop the questions that you do have now to get them answered live. But if you do have any questions outside of data modeling, you can go to our MongoDB community forum for those questions. I will drop that into the chat as well.
Cool, so I see a question from Michael Giuliano, sorry if I mispronounced that. Are there any webinars or resources that talk about the best way to handle collection locking? For example, I don't want someone in Europe to change a document while someone in the USA is making that change. So the best way to handle collection locking is to use atomic updates, right? So when you use MongoDB operations on a single document, they're atomic, meaning if two users try to update the same document, MongoDB will ensure that only one operation completes at a single time, right? So that atomicity applies to updates, inserts, and deletes. And make sure to just involve using a version field to your document so that updates only occur if the version matches that expected value. Um, on top of that, we handle all the ACID transactions uh, automatically. You just have to make sure you're storing that session in your database. I see Josh Lebowie ask, for a primary key, are there any downsides to not using object ID, or should object ID be preferred? Yeah, good question. So it's not mandatory, but there are several benefits. There are several cons depending on your specific use case, right? So some of the advantages, this is going to be globally unique. So you don't have to worry about generating your own unique IDs within your application. It's very space efficient and compact. It's only about 12 bytes or 24 characters, which is smaller than a UUID. And there is a timestamp that it will be embedded in your object ID to make sure that your documents are going to be naturally ordered when they're created. And all of this is native within Mongo. So these are optimized for your indexing, for all your queries, right? So this is your default primary key. Some of the disadvantages, they're not human readable, so it could be harder to debug. There's no application context as well, so you don't get a lot of information from the object ID, and you don't have a lot of control over that. So this is all going to be handled by MongoDB for you. So it all just depends on your use case. Drabo Mohammed asks, on white side MongoDB cap theorem are. So cap theorem within MongoDB, it's going to offer you that tunable consistency so that you're able to lean towards the availability and the partition tolerance depending on how you are configuring your data, right? So every read receives the most recent write or an error. There's not going to be any stale data. It's always available. So every request will receive a non-error response for that most recent data. And of course, since we are NoSQL, we have that partition tolerance. The system will continue to operate even if there are network partitions or any sort of downtime within your application. This is all going to be tunable. Your consistency will be tunable depending on your read preference, your write concerns, and again, you can allow your application to adjust read preferences, write concerns to balance that consistency and availability to meet those specific needs of your application. Is there any tool here in Mystery asks, is there any tool for modeling data for MongoDB, such as Irwin for relational table decide? We do have a couple tabular modeling tools that you can use. I know there's one called Hackalade, specifically for NoSQL databases like MongoDB. But you can also go ahead and use our MongoDB relational migrator. From there, you're able to migrate your SQL data. And if you are using SQL data, you can migrate your SQL data and kind of model your schema, play around with the different tables to see how it would look like within MongoDB. On top of that, we also have MongoDB Compass, which is the official MongoDB GUI. this is also going to help provide with schema analysis. So you can see your schema tabs, you can visualize your fields, your arrays, your nested documents, all these values. And this is going to be really beneficial if you're already using MongoDB. Steve Zach asks, what deviations are required for model design when a document contains multiple layers of arrays? Good question. So this is going to pose a lot of unique challenges for your schema design. Um, it just depends on how complex your query is. So deeply nested arrays are going to make it harder to read and write, especially when you're accessing or updating these elements within these nested arrays. And even your index performance could suffer because of that, right? So there's always going to be considerations. You have to understand your data access patterns. If you have frequent reads, you want to take advantage of the embedding arrays when they're queried alongside the parent document. Otherwise, if you have frequent updates, you are going to be considering whether or not you want to reference to avoid the overhead that's created when you're rewriting large documents, right? And then you have the consideration of small arrays versus large arrays. If you have small arrays, embedding will work well because you have a limited number of elements. Whereas if you have a large array and it's continuously growing, you want to reference these large arrays in separate collections to prevent oversized documents, to prevent index bloat, and again, to improve your overall query performance. And then from there, you can unwind these arrays within your aggregation pipeline for querying as well. Ahmed Rashid asks, does it support different data types like we have in relational databases? Yes, MongoDB supports all different types of data, comparable to data types found in RDBMS, but there are some differences due to the fact that we are document oriented. We have that schema flexibility. We use binary JSON to store this data, so we can allow for a rich set of data types and queries. So we store strings, numbers, decimals, booleans, dates, arrays, embedded documents. These are all just some of the basic ones. You can find a whole list of data types in our MongoDB documentation if you just want to go ahead and search data types in our document, in our MongoDB docs page. Marshall Dunn asks, I understand that data access together should be stored together, although what if we are defining a form's fields and characteristics in one collection as templates and using another collection to reference the templates collection to track all of the instances where the templates are filled with data? Is this okay? At what point would performance be impacted? Great question. Again, this is going to align with that principle of normalization or referencing and how this can work well for scenarios where templates are going to be reused across many instances. This design is going to be okay because you're actually reusing those templates. Storing templates allows you to reuse that structure across multiple instances. So you don't have that data duplication. This is going to keep your data consistent as well. So if you're modifying a field, this will automatically apply to all your instances. So you have that consistency. And again, you have that efficiency as well, right? So you're avoiding storing that redundant data in each form of each instance. When your performance is going to be impacted, can be due to several scenarios with your design, right? So if you have a high query complexity, you might have joins, and we don't support server-side joins natively like relational databases, but we do have $ lookups within aggregation pipelines. That's how we handle these sort of joins with our references, but this could be not only a little bit more expensive computationally, but can be more expensive as you start to scale. So do bear in mind that if you are using a lot of lookups, this could be quite expensive CPU wise. On top of that, if you have frequent template changes, if you're constantly updating your templates, it can cause inconsistencies, or um, you might have to have some sort of migration for your old form instances that reference that outdated template. And again, if you have large or even complex templates, um, this could be a consideration as well. So just bear in mind, data modeling is all based off of your application's performance, and it does take some time to test to see which is the most efficient. Mohammed Azim asks, what isolation level does MongoDB use? So we provide isolation at the document level, so that ensures that all updates to a single document are going to be atomic. We don't support traditional isolation levels, such as read committed, uncommitted, repeatable reads, serialize, just because our document isolation behavior is sort of tailored for distributed document architecture. So uh, all these inserts, updates, deletes, all this CRUD functionality is going to be atomic, and all these operations are going to be applied in its entirety or not at all. We also provide concurrent writes to the same documents, and those are serialized as well, so that no two operations can modify the same document at the same time.
Thank you so much, Irvin, for answering the vast amount of questions. And thank you so much, everyone, for joining today's webinar. We are out of time, but if you do have any more questions that didn't get answered today, please feel free to click the link that I just dropped in the chat to our MongoDB community forums, where you can get your answers question there. But thank you again for attending. We invite you to reach out and look for an email with us with the recording link and additional resources from today's webinar. I hope you all enjoy the rest of your days and have a great weekend.